Hi everyone. Today is the second workshop dedicated to the launch of Rarimal's ZKL rollup, and today we will discuss the ZK passport registry, and we'll build a simple airdrop application that uses ZK passport technology to verify the age of the person claiming the tokens. So let's start with a brief introduction as we are waiting from our viewers. I'm Ihor, I'm DevRel at Rarilabs and a contributor to Rarima protocol. I was involved in the crypto space since 2015, and you can follow me on X for more updates on Rarimal and its tech. Today we will discuss such topics as overview of Rarimal's ZK registries in general, yesterday's broadcast has had some technical issues, so we will revisit it in detail today. We will discuss the particular registry, the ZK passport registry, and we will get some hands-on experience with this registry by building a simple DApp that allows to claim tokens for everyone who is over age of 21, and then we're gonna have a small Q&A session. So let's get started with Rarimo ZK registry vision. What's it's all about? At Rarimo, we strongly believe at building a new type of infrastructure for decentralized social protocols that allows users to keep all their private data, such as their identities, their social graph, completely owned by the users and private to the world, but also it allows to expose some information about all this to the applications using the ZK proof technology. So what makes a ZK registry? First of all, we have proposed ERC-7812 that you can see on the screen today. What it basically does, it provides a framework for building permissionless identity registries on chain. It consists of two parts. First one is actual evidence registry. You can think of it as like an abstract interface that will be implemented by all the particular type of registry. And EvidenceDB, this is like a simple data structure that allows to basically commit and update statements in a sparse Merkle tree. Let's have a brief look at the EvidenceDB interface. We have basic CRUD functions, we have the SMT roots and other essential stuff. The evidence registry provides methods for adding statements and removing statements. and to make something working with it, we need, in addition to this ERC-7812 stuff, some way to trustlessly assert user's identity. There are multiple implementations of such registries, and today we talk about a particular one, the passport registry. What it is basically a vampire attack on government's biometric passport infrastructure. It allows users to scan their passport on their mobile device and generate zero-knowledge proof of passport validity. Importantly, absolutely no private data ever leaves your device. It's all client-side proven, so it's secure in that regard. Then we take this proof of validity and use it to commit your identity to a ZK registry. So later you can use this commitment to basically prove ownership of a valid passport, and on top of that, things like uniqueness proofs, proofs of some attributes of your identity, such as age, which we will use today. There are also some benefits to having a single global registry of passports, because there exists such problem as dictionary attacks. What it is? Basically, the government that issued the passports may want to infer who of the citizens use some particular application, maybe like a politically sensitive use case or something like that. So when we have a global register of passports, this problem is mitigated by providing some plausible deniability. Basically, the government may know that you are added to the registry, but has no way of verifying which apps you used later with this registry. So the more people join, the more dApps use this technology, the more plausible deniability each user gets. So it's like a privacy network effect. Let's discuss a little bit how it works from the developer perspective. To use this registry, user needs to download RORIMI mobile app, scan their passport using NFC, go through a simple onboarding process, and from that point they are good to go to use passport proofs with any decentralized application. When a DApp needs to verify some data, basically they need to generate a QR code that will be scanned by RORIMI app. This QR code will contain a query that we want to verify, like that the age is in some bracket, or the user is a citizen of a particular country, or we want to verify uniqueness. So one passport may be used just once, but like it's done in a way that doesn't reveal which passport was used. And also a callback URL that the RARIME app will send a generated zero-knowledge proof to. From that on, the proof may be verified both on-chain and off-chain, and in both cases the proof will be checked against the actual state of our DK passport registry on-chain to make sure that the passport was verified before and added to the registry, wasn't revoked, and stuff like that. So let's move on to a particular use case which we are trying to implement today. As I mentioned before, it's an airdrop. One second. So the idea of this app that we have give me a moment. Right. So with this app we want to collect the zero-knowledge proof of users' legal age on the front end, and get that proof from the app to app's backend, and then allow user to submit this proof on chain to get it verified on the airdrop contract and to claim the tokens. Guess let's start with airdrop's smart contract. So it's a pretty basic ERC-20 contract, but we have the claim function that accepts the zero-knowledge proof of age. We use snark proofs with gross 16 verification system, and it also accepts the root of the registry to check against, and once all the proof signals are verified, we mint the tokens to user. Let's then look at the application side. Basically, there are two important parts. To the left, you see so-called proof params. It's the stuff that is embedded in the QR code displayed on the front end. Here we have encoded birth date ranges. These are like two timestamps that correspond to our desired range. We have a callback URL that the proof will be sent to. Here you can see some other options that we can use, like check for the passport expiration date. We may check for user's citizenship. We may selectively reveal some passport fields via bitmask that you can study more in our documentation. And also we have an important parameter called event ID. It's like basically a scoping mechanism. It should be unique for every application, so the proofs couldn't be shared between them without user's intention. And on the client side, on the right, we submit the received signals to the token airdrop contract, and by calling the claim method we get the tokens. So let's try to actually run it. So let's start by connecting my MetaMask. Here you can see the QR code for RME application that I need to scan with my RME application. Here how it looks like. Here we have the scan QR button. We scan the code, we get prompted to generate a zero knowledge proof of age. Let's accept it. It went through. The application successfully received it, so let's submit the transaction and claim the contract. Claims and tokens, sorry. So we should have received the tokens. Let me check my MetaMask. Seems like it's good to go. So the integration of ZK passport proofs is pretty straightforward, both on-chain and off-chain. For the off-chain use case, we have a small self-hosted service that you can spin up in Docker and check the proofs against it via pretty simple REST API. So there is no issue with supporting zero knowledge proof verification to different languages and platforms. It's all pretty straightforward. So let's check chat if we have any questions. Okay. Looks like we missed the live chat and the broadcast settings, but it's okay. I will share the link to the documentation regarding both ZK passport and the ERC-7812 and also the code for this demo. And the last thing, we are looking to engage with the developer community more and need your feedback regarding our technology, and also we want to give you some exclusive access to some of our developer incentives. So if you have time, please fill this type form that I will share during this broadcast. And I think that's it for today. See you.